Hello folks, here's our next lesson. Notes number 52, Permutations. Get yourself ready. Do you have your pencil and your notebook? And are you wearing your glasses? Remember, always wear glasses to math class. They help division. Get it? Division. Wish I could hear you not laughing and see you half smiling out there. Okay, let's pick up where we left off last time. Remember when you were in jail making license plates, and one of the problems you did was figuring out how many different license plates were possible if repeats are not allowed and your license plate has 2 letters followed by 5 digits. So what we're going to do is remember what we did. We had the spots for the 2 letters and then we had the spots for the 5 digits, and we listed how many ways there were to do each part of the process. So for the first letter, there are 26 options, and then because we're not repeating, for the second letter there are only 25 options, and then we're moving on to digits. So for the first digit there was 10 options, and then we're not repeating, so then 9, and then 8, and then 7, and then 6, and we calculated that number. But we didn't talk about how what we're seeing here looks like partial factorials, so we're going to delve into that here today. So I'm modifying the question a little bit. How many different ways can 2 letters be selected from a group of 26 distinct letters? So that's like the first part of the license plate. You're only selecting 2 letters. You have 26 to start with, and then you have 25 left. Okay, do you see how that looks like a partial factorial? So if it was 26 factorial, you'd have 26 times 25 times 24 times 23, and so on and so on and so on. But instead of that, we don't have the 24, the 23, and all of those. So it's like we have 26 times 25 times 24 factorial over 24 factorial. So it's like 26 factorial over 24 factorial, and the 24 factorials cancel. Now let's take a look at the second part of the license plate with the 5 digits. And you're selecting from 10 digits because 0 through 9 is a set of 10 digits. So let's see here. We have 10 choices, 9 choices, 8 choices, 7 choices, 6 choices. So doesn't that look like a part of the 10 factorial? That looks like we took 10 factorial and divided it by what? Well, we don't have the 5, the 4, the 3, the 2, and the 1, so it looks like we divided it by 5 factorial. Okay, so if we analyze each of these, looking at the numerators, we can tell where the 26 factorial and the 10 factorial comes from. The 26 is the total number of letters available, and the 10 was the total number of digits available. But how about the 24 and the 5? Where do those come from? So if you used 2 letters, you have 24 that you didn't use, and if you used 5 digits, you have 5 that you didn't use. So that's the number of letters or digits that wasn't used. So now we're going to generalize this. How many different ways can R letters be selected from a group of 26 distinct letters? So R is a number, a whole number between 0 and 26. Let's make that assumption. And you're using R letters, so you're not using how many? You're not using 26 minus R. So your numerator is going to be 26 factorial, but your denominator is going to be 26 minus R factorial. And then generalizing even more, how many different ways can R objects be selected from a group of n distinct objects? So you have n factorial on the top, and then you have n minus R factorial on the bottom. This leads us to what we call permutations and the permutation formula. Permutations are the ways you can rearrange things where order matters. So we've been doing permutations all along. The number of permutations of R objects taken from a group of n distinct objects is denoted by this notation. I say NPR, like National Public Radio, NPR, and is given by this formula. NPR equals n factorial divided by n minus R factorial. NPR can also be written like this, a P with the N and the R in parentheses vertically, and a P with the N and the R in parentheses horizontally. I've seen all three. It just depends on the preferences of the mathematician. Now you do have a permutations button in your calculator, and it's in your shortcut menu also, and I made a short video of that for you, so you can watch that one too. Okay, we're going to do a few more examples. Number 1, how many different ways can 4 raffle tickets be selected from 50 tickets if each ticket wins a different prize? Okay, so it's like you have 4 distinct things because each one has a different prize. So what's the total number of objects? That would be 50. And how many are being selected? That would be 4. So we have 50p4. And if you were working that out by hand, that would be 50 factorial divided by 50 minus 4 factorial. And you could expand that and you could work that out by hand. It's equivalent to 50 factorial over 46 factorial. So if you did have to do that by hand, all you would be doing is 50 times 49 times 48 times 47. So that wouldn't be too bad. But instead, if you want to use your permutation button, you get 5,527,200. That kind of makes it feel like you're maybe not going to do so well in this raffle. That's what I'm thinking. Okay, let's see what number 2 is. In how many different orders can 4 students be interviewed for CBTV? Okay, so you have 4 distinct objects, the students, but all 4 of them are being interviewed. So this is 4p4. And that would be equivalent to 4 factorial divided by 4 minus 4 factorial. And that is 4 factorial divided by 0 factorial. So do you remember in our last lesson when we learned that the definition of 0 factorial is 1? Now hopefully you'll understand why it's 1. Because, first of all, you can't divide by 0, so you know it can't be 0. And also, if you think about how we might have done this problem last time, we would have said, okay, let's make a slot representing the first one interviewed, the second one interviewed, the third one interviewed, and the fourth one interviewed, and we could just work it out like this. There are 4 choices for who's interviewed first, and then there are 3 choices for the second, and then there are 2 choices, and then there are 1. So that would just be 4 factorial. So we need 4p4 to also be equivalent to 4 factorial. And the only way that's going to happen is if 0 factorial is equivalent to 1. And then that works out to be 24. Okay. Now, what if objects are not distinct? For example, let's say you have the word Yahoo, and you want to rearrange all the letters. And you want to list the distinguishable permutations. See, there's 2 zeros, or two O's, and they're not distinguishable. You can't tell them apart. So you could write a word, Yahoo, and another word, Yahoo, that has the O's in the different order, but you can't tell that they're different. And so what we have to do is figure out how to account for that. So first of all, to rearrange the 5 letters, you would have 5 factorial, but then you divide by the number of repeats. So you have twice as many as you want because of the 2 O's and being able to switch them around. So we're going to divide this by 2. 5 factorial divided by 2 would be 60. Now what if Yahoo has 3 O's? Well, when it had 2 O's, we divided by 2. When it has 3 O's, do we divide by 3? That would make sense in terms of a pattern, but we don't have much of a pattern to go on. So let's think about this. What if we called the O's O1, O2, and O3? How many ways are there to rearrange those? We could have that. We could have O1, O3, O2. We could have O2, O1, O3. We could have O2, O3, O1. We could have O3, O2, O1, and we could have O3, O1, O2. There are 6 ways to rearrange the 3 O's. Now that should make sense to you because 6 is 3 factorial. 3 choices for the first one times 2 choices for the second one times 1 choice for the third one. So we need to take the total number of letters, 6, so 6 factorial, and divided by 3 factorial to account for all the repeated OOOs that we have in this problem. Okay. Number 5. Find the number of distinguishable permutations of the letters in Yippee Yahoo. Okay. How many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 letters. So we're going to start with 14 factorial, but then, because of the repeats, we're going to have to divide by something factorial, and we're going to have to do that multiple times. How many y's do we have? 1, 2. So we're going to need to divide by 2 factorial to account for the multiple y's. How many i's? Only 1 y. How many p's? 2 p's. So we're going to have to divide by 2 factorial to account for the 2 p's. How many e's? 1, 2, 3, 4. We're going to have to divide by 4 factorial to account for all the e's. And there's only 1 a, and there's only 1 h, and there are 3 o's. So divide by 3 factorial to account for all the o's. Now when you put this in your calculator, if you're well, it depends on how you decide to type it in, but you may need to put parentheses around your whole denominator if you want to type this. 14 factorial divided by, parentheses, 2 factorial times 2 factorial times 4 factorial times 3 factorial. Or if you want to type it in like this, you won't need parentheses. 14 factorial divided by 2 factorial, divided by 2 factorial, divided by 4 factorial, divided by 3 factorial. You can do it either way. Let's see what we get. I got a number so big I don't know if I can squeeze it in this space. 151,351,200. Is that what you got? Well, yippee yahoo. Okay. So then we have a formula for this. They're called permutations with repetition. The number of distinguishable permutations of n objects where one object is repeated s1 times, or s sub 1, another is repeated s sub 2 times, and so on, is n factorial divided by all those repeats factorial. Okay? There we have it. Okie dokie. Here's your assignment. You got a little bit of using your calculator to do permutations. You got a little bit of figuring out the number of distinguishable permutations, just kind of a little smattering of everything. Have fun with that. Thanks, everybody.